Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Last class we have seen an example of concurrent programming. We have seen the lecture, and basically the lecture covered several aspects of concurrent programming. It was talking about examples of how threads work and how threads are created. So you have seen those examples, and we started up having this discussion where we said we need to be able to be familiar with basic programming constructs and also basics of Java. So and then in order to understand these kind of programs where you have object-oriented programs, you should have some understanding of Java. So we will start there. Today we'll try to have some practice, and last class we were trying to create some examples, and we have this example here. We created an example of an array list where we were trying to find the maximum value, and also we were trying to display it. So I would actually assume that you have these skills, you have some of the basic skills at least. You don't have to know all of them, you don't have to know everything in Java, but if you don't know any Java, then you should really get back to the management and see if you can take this module later, because I'm really sure that you'll have a difficult time creating the assignment and also responding to the assignment questions. So that may be an issue. Primarily these modules are hard for third year students, and you must have taken Java in your year 1. So if you haven't taken Java 1, then you should opt out of this module. That's how I see that. Okay guys, now for the case of this specific example, we have a small class here. So basically any class that includes methods inside a class is object oriented. Let me try to display that first for you guys. This is an example of a small function that has something called a main function. It has basic procedural programming. So when we say procedural programming, we mean that it has functions and it has a main function, another function, it goes on like that. When we say object oriented programming, then the concept is a little bit different, of course. So let us try to have that idea here. I'm going to create a new project here to show that to you guys. So file, new project. Again, if you have NetBeans, that will be better. You can follow my tutorial. If you have something else, you may have different examples. So object oriented programming, example class. Okay, example tutorial, you can say better. You can follow this along, or you can make your own tutorial on Eclipse or IntelliJ or anything you are using currently. Alright, so here is an example of a class. You see, a class called OOP example tutorial. This is the main class. Every Java program starts with the main class, right? So you have this class. Now what we'll do is we'll create another class. Into this one we will add, let's say, a class. So I'm going to create a class, a new Java class. I'll call this as a bank account. Let's say bank account, and this is the standard way to create it. You have to use capital letters, and this is every second word is also camel cast. So you should understand these kind of constructs. Public class bank account, so it may have some variables. Any bank account going to have a bank account number, so we'll make a string called bank account number. So account number, some people will use underscore here. I use this way, this is better. Camel casing is much better. And also it's also going to have a balance. So there is an account number and it has some money in it. So balance. Okay, you can call it account balance if you like. That is kind of better because it gives more meaning, right? Account balance. Then you have to make this B capital. And then also you may have someone who is holding up the account. So private string customer. Now here is another problem. Customer himself has a name, he has an address, he has a phone number and those things. So you have to create a new class for customer. So create a new class for customer. Let's call this as customer, not customer. And the customer is going to have his own methods, let's say. So he is going to have a name, private string. We will try to stick by the name, basic things, ID card number. Every customer must have an ID card number, else there may be two people with the same name. ID card number, I'll call this like this. And then of course we assume they have a single name for this case. Private string name. Okay, you can say name, customer name. I like to give customer name, customer ID card number. So okay, ID card number. So customer name, at least up to this. Okay, you know that you have address, contact number, date of birth, and blah 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 information about customer might actually exist. So here in the customer class, you have to first create a customer before you can add here into the customer. So instead of a normal variable, these variables like double, string, they are called primitive data types. But this one is called reference data type. Bank account is a reference data type. Customer is a reference data type. Okay, so when you create a class here for customer, you can use customer in this case. Customer, so here's the customer, so you can give customer. You have a customer also. Okay, now you have something known as a constructor. So every object oriented program or every class will have a constructor. So you can either write it, if you are in NetBeans, you can actually generate it, insert code for the constructor. And first we will not choose anything, and we will try like this. This is called a default constructor. A default constructor is something that has no specific arguments. See, it has the same name as the class name and no arguments, meaning no parameters. Then you are going to do is you are just going to assign basic values by default values. So you can say account number is going to be nothing, empty for now, and also account balance is also going to be for now 0 0. So that means when you create a variable or object, that's not going to have any value. By default it will be 0 or null, something like this. So not null, of course, something. So equal to new customer. Again, you see, this is a customer you are trying to create, and this customer class doesn't have a constructor. So you have to go to the customer class and create a constructor there also. You need a constructor here, insert code for the constructor. Okay, so again, default constructor with nothing, and default constructor is just going to assign customer ID card number is equal to the customer name. Initially when you create an object, you don't have information, so they are just going to have a default value, and default value is in this case empty string. So in this case, when you create a customer, it actually assigns basic values of customer, doesn't give any details, but just empty values. That is bank account. Now you create what is known as insert code for constructor. Again, you select everything, and then this is called a overloaded constructor. An overloaded constructor has the same name as the constructor or the class, but it has parameters. And the need for using this one is when you want to create a bank account, you can directly give the data. Or the same thing here, let's go to the customer class. We create a new constructor here. You could either type the whole thing or you can generate. Select all, generate. You can write it like this. Okay, public customer, it has ID card number and customer name as variables, and then we assign them into the class variables. This is called an overloaded constructor. Okay, they are the same, but the difference is this one already has the parameters. I'll tell you how we use them, for example. Okay, so in the bank account now we have the details, and here this is going to be a little bit of problem because you have information about a customer. So how are you going to assign this information? So in this case, you have a string, you have a double, and you have a customer, not information about the customer. Directly you are sending a customer there. Okay, so you have to create the customer outside, send it into the bank account. Right, so another important thing is the getters and setters. These are member variables and they are private, which means no one can access them. So you have to allow them to be accessible, and that you do by using getters and setters. So generate the getters and setters, and there it is. Okay, so you have to type them out, of course, if you are using an environment which doesn't allow you to generate. So the basic idea is if you are creating a getter, then it has this get in front of it followed by the variable number, name, and of course it doesn't have to be that way. You can create in any name you want, but when you generate it or when you follow the standard, this is how it looks like. A return type is the same as this type. You see, you have to look for the variable data type. You are trying to return an account number which is a string, therefore your return type is a string. In this case, account number, you are returning an account number which is a double value, so you are returning a double value. These things you must be familiar because you have studied methods, right? And if you are using a setter, for example, in this case you are setting up an account number, therefore you are not going to return anything, so there is no return. Void means no return statement. So there is no return line. It's just an assignment. Okay, you should know these basic things when it comes to object-oriented programming. And then you have at the end here what we know as the toString method, and the toString method is actually allowing you to get customer information. For example, you insert code using the toString method, see, and then of course for you have to type them out if you don't already have them, and it automatically inserts this override here. This is because toString is coming from the object class. The object class is the parent class of all Java classes. So even if you have not added here, there is an implicit extends object here. You don't see that because compiler actually uses that implicitly. So override is appearing because it comes from parent class. In this case, there is an implicit inheritance. Don't worry about that much, just type it as it is. So basically the idea is this is going to return some data, and this is what it returns, just some output in a specific format. Okay, we will stick to that. Also, let's go to the customer. In the customer also you have to insert those things. You have to insert the getters and setters. So customer also getters and setters for all the variables, and at the end you have to insert the code for toString method. Now if you are not using this, you have to use your own code editor and type them out. So you can pause the video, look at these codes, and I want you to type them. That is the idea of practice, right? You have to type them out, and there's not a problem here. See the way it looks like. Maybe you want me to scroll them, so it's just a random way of displaying them. It returns a string actually. See, the strings method returns a string. So this is an output. It is just going to show in a specific order, and you can see here at the end it has customer equal customer. This is not going to work, so this one you have to change by putting here customer dot to string. So customer information you will display separately by calling the customers dot to string method, which in this case calls to this function, and then it also gives a specific output in terms of a string, right? Let's see how it works. So let's try to create a customer first. In this example, we create a customer first. So by using the default constructor, what we do is this: customer equal, let's say, new customer. We don't know the customer name, right? So we create a customer, and then we don't know his name, so we have to, of course, remember you have to make sure that they are in the same package. See, customer, what is this error? Cannot find single variable customer. Customer is in the same package. So example tutorial. Yes, you can see from here. Yeah, it's in the same. Customer equal new customer. Do I have sorry, variable? Where's the variable? Simple mistakes. Okay, customer equal new customer. Now you have no details about the customer. See, for example, customer sout means you print out system.out.println customer information. You don't need this. You can just say customer.toString. Run it. See, it gives nothing. It's basic information. Customer name and everything is going to be empty. See, because you didn't assign them, you don't know them. So if you don't know them, you have to ask the user, right? So what you do is you ask the user to enter them. So you say customer.set customer ID card number first. So what is his ID card number? We don't know, so we have to ask the user. So we can say j option pan dot show input dialog. Okay, and then you'll say actually you're just going to ask, please enter, this is his ID card number. This is a short way of asking, of course. So we are using this graphical little class called JOptionPan, and you have to make sure you import it here. If you don't import it, you can just press Ctrl Shift I in NetBeans and it imports for you. This is customer's ID card number, and then the same way we have to set customer dot set his name. Right now we only know his phone number, so we can use the same thing, copy paste this one here, and then we ask him to enter his name. So this is the customer information. Therefore this information is sent into the customer. Now if we print, we have the customer information. Let's try. So run it, and so asks ID card number A0, for example, and then name. Yeah, see, customer name, customer ID card number, because this information comes from this user input. So if you don't know the information, you can of course create them by asking the user. This is one step. The second step is, if you know the information, let's say this information comes from a database, or you already know them, then you can use the default constructor, so the overloader constructor. See, if you know the details, you can directly send it across ID card number and customer name. So you can say what is the customer ID card number? A0, for example, comma, what is his name, like this, for example. Now if you have this customer and then you try to, okay, so there seems an error again. Okay, you can't use customer, so let's say customer 2. This is another user, so there you have it. You can just call the name you want, right? And let's say again you can do the same thing. This time you already know the information, so you just print them, and you are going to print information about Monica. See, so first information it asks us, the second time it doesn't ask us because we have already assigned them. So if you know the details, you can do this directly, this ordered constructor. That's why we use ordered constructor, and this is how we use default constructor. So for both of them, let's create an account. Let me first show you. So first case it asks us because we don't know the information, and then it asks the name, not worry about the name so much. So see here, this information we entered, this information it knows, so it has created the customer directly. So we have 2 customers now, right? Okay, let's create an account. So in this case we are going to create an account by ourselves by making, we don't have much details. This is not an account type bank of so there is no specific bank. It's just an example, right? So we need an account number and the account balance and the customer. So let's create a customer here, bank account, and then in this case we will say current account. Okay, let's say customer current account, summarize like this, right? Equal new bank account. And this example of what we were referring to when we say object-oriented programming. So a little bit of test of OOP is needed for you guys, so that's why I'm doing this. So here, if you know the account number, so let's say account numbers usually start with an example. Just choose an example from Bank of Modus. So like this example. So what's the account type? Is it account type? What's the second argument? Account balance. Oh, balance is a double value. So let's say, let's put some money into this guy's account. So we have 3,545 rupiah, 25 lari, for example. And then he also has a customer. Who is this guy? It's this guy. It is this customer. So if you have a list of customers, you can of course create it that way also. This is a basic example of creating a bank account. Now let's try to show the details of this bank account. Okay, so again you need a print function, and then you need to send this account details and to string. So this is the information about this bank accounts. So we have an account for this guy, right? This guy. So let's try to do this now. So we have a customer here, ID card number, name, and then the second case, of course, see, first customer information it asks us, second customer information already exists in the system, and the bank account was created for this customer. See, this customer that we have created, Hussein Ali. Yeah, Hussein Ali. So it prints the information about the customer as well as it prints information about the bank account. So this is an example of a small object-oriented program where you can associate objects inside objects. You have an object called customer inside your bank account class. So this kind of example, you must have tried them. If you didn't, I want you to try them now. Follow this example, try this out. This is how we create a simple object-oriented program with no inheritance, no polymorphism. Okay, this concept of encapsulation you may have heard. This is encapsulation. You are making this private and you are sending them through getters and setters. Okay, that is encapsulation, hiding, data hiding. So this is the bank account, customer to string method, and because this has customer to string here, it is able to print the customer details. When you see the output has customer details here, see, because we have already used to string method there also. So this is just an example of a small program that you have to try. Okay, so that is the idea of the application there. Now let's go back to the application we were trying on our example here. In this case, I want to just explain to you, and I want you to type them, of course. So uh, this is the example we just created. This is the GUI application there, I guess. Yes, okay. So this one also I want you to type it out and try it yourself. Find a Java environment where you can practice it. Okay. So in a setup where we are in a face-to-face classroom, that you can do it in front of me. But right now, because you are not there, I can't actually ensure that you are doing this. So I really urge you to try this, guys. If you don't, you will not learn these things. If you are taking the time for granted and just being free and enjoying, you're never going to learn these things. So this is your class period, class time. I want you to spend time on practicing them and not use it for something else. Use it wisely. A particle has a location where it appears in a graphical window, x and y coordinates of where the particle is located. And then you have a random number where you are locating a specific particle. So that random number is a final, meaning it doesn't change. You are not allowed to change it. It has a value, and that value is the final value, and you are not going to generate a new random number from it. So there is one random number, and there it is. It stays like that. It cannot be changed. Okay. And then this is the constructor, just like the way we created. See, particle has a particle constructor, and it is a overloaded constructor because we can see it has variables inside it. Now every class does not need to have a default constructor. By default there will be a default constructor anyways, but it doesn't have any details. It's just going to be null. It is there because implicitly it will exist. So you have to create an overloaded constructor if you need it, in this case like that. So you create a particle, send these variables across. That way you are able to assign the variables of member variables x and y. And you have seen here they are not private, they are protected. That is also fine, because in case sometimes you want to use subclasses where they have to access these variables, they have to be in protected states. So if you put them in private state, then you need variables where you can get and set them. Okay. So here you have another example of a function called move. Now move is just like a normal function, like what you see here in the bank account, for example, just like one of these functions. Move is a function. So what does move do? Move is used to move the particle from a location to another location, and that location is determined by this random number. So from the random number you are identifying x-axis is equal to the random number dot next integer 10 minus 5. So this is just going to subtract some values from the location. So every particle is going to be randomly placed in a different location, and it has synchronized keyword here, and this is what we will study later on. The purpose of synchronized keyword, the purpose of volatile atomicity, those things we have to study as separate concepts. But generally speaking, this means no one else is allowed to access x and y while one of the thread is using this method. Okay, that's why you have this keyword called synchronize. It allows threads to wait until someone else is done with the moving. So which means one thread will move the particle while the other thread tries to draw that particle. So what will happen is you are not going to move a particle that is being drawn. That's why you have synchronous keyword here, meaning you will only move an item independently. So you can't move an item which is being drawn, something like that. So that's why you have synchronous keyword here. Okay, so after an item has been moved, then this method is used to draw it. And of course you can already see here, this is also one of the methods of this class. So you have public void draw graphics, and then you have some these are the coordinates, how to draw it. Again, you have a synchronized way to access the value, because x and y should be synchronized, meaning this has to have a specific value of x and y, and that x and y value should be a value that is taken synchronously. What is the value of this particle at this given point of time? That should be accurate. That's why you are using synchronous keyword, allowing other people not to access the x and y value while you read it. Okay, so that's the idea here. And also this is the way you are going to draw a rectangle. So that small square comes from this method. So this method alone can't create anything, it can't draw itself. So it has a method, that can allow it to be used. So in order to use it, what we do is we create a small canvas in Java. Of course you don't have to know everything about the canvas, But remember, this is just a piece of paper where you're going to draw it. So this class extends canvas, and it has this idea of number of particles that you're going to place, and those particles will be sent to be drawn. So you have a canvas of this x number of size, and size is also determined by someone else. That means the size of the paper, the size of what you are drawing. And then again you have here a synchronized method called void set particles. So you are going to set particles, so which means if you set particles, no one else will set more particles. It's just going to be one instance of assigning particles. So like that it goes on. So you have assigned the particles into the uh, canvas. So you create particles, send them here, and those particles get assigned into this array. So my canvas have particles, just like the way we have used a customer in bank account. My canvas has particles, and those particles are the one that's going to be drawn and moved. Okay, then you have here a small method called get particles. So at any given point of time you want to receive all the particles in an array, and that is also going to be synchronized, meaning when you are reading the data, when you are getting all the particles at that specific point of time, no other thread is allowed to get those particles or set the properties of those particles. And then you have the paint method, so which is going to get all the particles, so you see get particles. So this get particle come from this function, it gets all the particles. So you said this is a separate array. It is a method specific, a local, it has a local significance, this array, although it has the same name as this ps. Oh, it's not ps, it's particle. See, this is ps. So these kind of variables that appear inside functions only only have a local significance. Outside the function, no one knows those variables. So here also you have a ps, and that is a completely different variable than this ps. Remember that one, okay? And only this function sees it. Others don't see this variable. So particle array is equal to all the particles of this class, and for all the particles, one by one, what you are trying to do is you are trying to draw them. So draw is coming from the particle class. You can see there's a draw function, and then you are going to just draw it. That's what you do. Okay. All right. So in a canvas, we are drawing particles. Now we have the main thread class where you are actually doing the things. So what you are trying to do here is you are trying to create all these threads, and simultaneously trying to move all the particles and draw the particles. So you have a huge array of threads here which you are going to later assign, and then you have here a canvas, that is this canvas. So into the canvas, into the applet, so it's either a graphical frame or an applet, meaning you have an application where you are going to mount that canvas on, like it's like putting a canvas in your table, something like this, putting a canvas onto a flipboard or a board where you are starting to draw. So this is the applet in that case. So there you are placing this canvas, and then you are creating a thread where you're going to actually do what you have to do. And what you are doing is, in the case of this init function, when the applet begins, this is what happens. You are going to add that item onto the you're going to add the canvas into the application so that people will see it. So this is when the application begins, and then you have this thread. So it's a method, you see, is returning a thread. Function name is method. It has a parameter. This is the parameter. There is a particle, a single particle, and this is the function. So it returns a thread, and what is inside the thread? There is a runnable object. So if you listened correctly to the lecture, we were saying every thread only can work with a runnable object, or something that extends a runnable object. Sorry, not extends, implements a runnable object. So you are actually getting a direct runnable object in this case. So you are passing this run loop into this, and you are returning a thread for each particle. Okay, so you are returning a thread for each particle. In this case, of course, you are returning a thread for a particle, for one particle. And what does it thread do? It has a run method, and that means it actually moves the particle. So when you move the particle, p dot move, so here you can see this p is a particle, you get a particle and you are moving it. So after moving it, then you are calling canvas dot repaint, and because you have called repaint method, this is going to paint it again, and that way you are going to see the new location of those particles. Again, you are going to sleep for 1 second. See, 100 millisecond, that's not even 1 second. If you make it as 1000 millisecond, that is going to be 1 second. So if you make it 1000, that is 1 second, right? It's in milliseconds. And this is a infinite loop, I mean continuously it's going to do this. There is no end in this specific scenario. Okay, so that's what it does. So just make sure that you understand what is happening here. You have a small object that's been created, a runnable object. Actually everything here is going to be in one line. It is being inserted this way so that you understand what's happening, but this is one variable definition really. Okay, and then you have the start method, which is going to start the tab, the applet, because it's going to start. That means start, right? So start and stop are ways of starting and stopping the thread. In this case, it actually starts, but it never ends. So there is no stop until you close the application. So we created 50 items. So that's actually kind of too much, because you are going to have 50 threads there. That's not going to be efficient, right? So let's make it 10. And then threads initially is going to be null, and you can see here this threads refers to the threads here in this class. So there are no threads initially, and then you are creating these particles. So there's 10 particles. After creating 10 particles, then you are going to associate them with the location, see, x and y location, and this is going to be where they are placed. You can see here particle has a constructor initial xy location, and then you are setting those particles into the canvas. So that's like drawing dots, 10 dots on a canvas on a specific location, right? And that location is 50, 50. So which means they are actually on the same position. Okay, so threads also like that. You are going to create 10 threads, and all the threads you are going to start. And how do you start the threads? You make a thread for each particle, and then you are going to start that thread. So 10 threads managing 10 different particles simultaneously. At the same time they are moving them, and it gets drawn. They are moving them, and it gets drawn. So that's the idea of the whole program here, and it is showing that in a graphical application, if you have threads, then you are going to see simultaneous actions. If it was a procedural program without threads, then you will actually see a scenario where one particle is moved, then it gets drawn, then another particle is moved, and it gets drawn. Like that, there will be a whole latency there. So we will see those examples also later on. Okay, so this is one of the programs that you have to try. Let's run it. Okay, this is an applet, so you have to run it from here. Now I have already explained to you how you will create the applet. You'll right click here and say new applet, new JApplet or normal applet also. If it doesn't appear here, you can just click others and choose from here the type of applet you want to create, and give it a name, and it appears here, and you configure it. Right click and then run file. That's how you are running that specific application. See, so they have been moved. Now we chose 1 second, that's why it's a little bit slow. 1 second, every 1 second, every 1 second they are moved, then they get drawn. 1 second they are moved, then they get drawn. You can actually make it bigger to see how they are getting drawn. See, here it is 10 10, so let's make it 20 20. So the particle is going to be a little bit bigger when it is drawn. Again, run the file, and then you will see a little bit bigger particles. So squares are a little bit bigger, more visible. So you have 10 items which are simultaneously moved. Every time you move them, they get drawn. Move them, they get drawn. So that is an idea which is kind of very nice, right? Okay. Now that is the first application we were trying. So we have seen an example of an OOP program. We have seen implementation of threads or concurrency in an application. And the other example that you have seen is related to this thread here, down here, yield method and thread class. Okay, before the GUI, there was a print task method. Okay, so this is the full class also for this class print character implements runnable, class thread demo, and class print num implements runnable. These three also I want you to try them. First you can type exactly what they have here, and then test it out using by giving here numbers, more numbers like 100 or 200 characters, 300 characters, 1000 characters, and see how it affects these threads. So in this case, this is a simple CLI output. It outputs A's, B's, and numbers, and because they are all working together simultaneously, you will see this kind of output. Okay, so you have the code here. I want you to type it out onto NetBeans and run it. And because our tutorial has got a little bit lengthy, I'm not going to type them out here. I actually had them here, and I don't know now where they are. Example codes. This is the application we were trying, isn't it? Yes. Yeah. So I would find it out, and also I will make a separate video for that where we are going to try. So in the probably in the Thursday's class we will try to execute this one, where we will try to play around with other types of methods associated with the thread class, and that is these things. We could work on starting, stopping, joining, sleeping, yielding, and interrupt. There are other methods also where we have to study. So thread class, you will be really getting time to know about it more and play around with more. That is one of the major things you have to do for your assignment, to do a thread related assignment. Okay guys, so thank you very much for watching. That's it for this tutorial, and every week we will have a lecture session, and then the tutorial session and the lecture session. That's how it will go on. Okay, thank you very much, and see you in the session.